welcome back to the Node Spaghetti. This is where we left off in the last video with the legs of the mech finished, our IKFK switch, our controllers that show and hide in the proper times, and our heal controller. We're going to go ahead and make those other parts in this video, and we're also going to make the arms and the hand, and maybe we'll even do something about these like bundles of wires or whatever those are. I haven't decided yet. Anyhow, let's get to it. Let me just go ahead and unhide the meta collection, show us our meta rig. Very cool. And just a refresher, this right here is our leg group, which has different components set up. These are our add object groups that add the different pieces to the rig. Let's go ahead and create a new bone, which is going to be the parent of the two legs. Let's add an inherit node and make it a child of the armature object. We'll call it CTRL for control torso. Plug it into the parent inputs of the leg node groups and press E to generate. And if we go ahead and unlock these transforms, we can see what this does. So obviously the torso is going to be in the wrong place unless we add a meta rig node, meta mech, and we want that torso bone, torso 1. Plug that in there. And that's a little bit better, but I'd like it to be in the center here, and I'd like its axes to line up with these world axes. So if I go ahead and in the armature display the axes, you can see its z-axis is this way, and its x-axis is in the right way, but its y-axis is wrong. So the z and the y-axis are rotated 90 degrees from where they should be. See that? So what we need to do is we need to go ahead and just set a matrix location, and you can see that when we set the location from an empty matrix to 0, the axes line up the way we want them to, and it's just in the wrong place. So we'll go ahead and get a point from bone matrix, plug the matrix inputs, plug the point input, press the E key to generate, and that's a lot better. Let's just slide it up onto the tail of that meta bone, and that's where we want it to be. Very good. I think I will go ahead and add reroute node here and here, just for the sake of organizing this a little bit. That feels a little bit better. Cool. Let's go ahead and add the other two bones, torso 1 and torso 2. We'll call them hips and chest, just because that's familiar language to us human beings, which are made out of, or made out of those things. So let's call this one hips. Let's go ahead and enable inherit rotation, and we can use this torso 1 matrix directly. And this is nice, but it's rotating from the wrong point. So we're going to go ahead and add a flip head tail matrix, and now you can see that it rotates from the point that we want it to. The head of the bone is up there in the middle. Very good. Finally, we want to add a chest. We'll call this one chest, and we'll make it the torso 2 matrix. Very good. Before we finish this section, let's go ahead and add all the objects in our mech collection to the tree so that we have a complete character, even if it doesn't have a complete rig yet. So and let me just go ahead and fix the names on these so you can see what these two parts do and what the torso control does. Cool. And let's just go ahead and add the arms, shoulder.l, upper arm.l, and lower arm.l. We can make all these children of the chest. Control Shift D to duplicate them with their inputs. And we'll just change the L's to R's. Press E to generate. There we have it. So the next thing we're going to want to do is just set up some custom controllers for the torso pieces. And we already know how to do that. We just add an existing object and then we name it here. We already made these square widgets in the last video. Let's just see. They're too small right now. I'd like that to be 3 times as wide.
And twice as deep. Very good. Use this to control how long it is. Or how long the bone is. And I think it's good where it is. Let's see, for the chest, we want it to be like 4 times as wide and 2.5 times as deep. A little bit too much. That's good. Can move it back a little bit.
When we're going to animate this mech, there's going to be times when it gets hit by artillery shells or something and it has to rock back and forth. Or maybe it falls to its knees. Boosh. And has to pivot from ground somewhere. Maybe it just falls over, flat on its back like that. In order to do that sort of animation, you either need to use the 3D cursor like I'm doing now, or you need a bone to serve as a pivot point. Now, we don't know ahead of time exactly where the animator is going to need the pivot point. Sometimes it's nice to just have an extra pivot that you can put anywhere you want. Let's do that. We're going to need to add a new bone, make it the parent to the torso so it can serve as a pivot for it. Torso pivot. Press E to generate. Let's have it inherit rotation. See, now we have our ground-based pivot. But if we wanted to move this to pivot from up here, you can see the whole mech moves. So just as before, just like what we did with these feet, see the movable pivot. We're going to do a counter pivot. Change its name, of course. And we can lock all of its transforms. And now if we generate this, we just need to do, just like before, copy location and invert all the axes, copy in local space, and take its parent as its target. And now we have our movable pivot, and you can see exactly what that does. So I think I'd like to put it in the same spot as our torso controller also. The counter pivot should copy the matrix from its parent. And of course we can hide it so we don't need to see it. There we go, we've got our new controller. One last thing, I've got a widget for it, which is called widget locator. That does not seem to be very even. There we go. So now we can set this pivot wherever we want, animate with it. And you might be wondering why. So you might be wondering, why do we even bother with this custom pivot if we can just select our torso here and use our 3D cursor as the pivot? It does the same thing, right? Now this is one of these situations where if you like to rig characters, it really helps to know a thing or two about animation. So let's go ahead and animate using our 3D cursor and see what happens. We'll have the mech fall flat on his face. See how it's following a straight line, and in fact, if I make a motion curve over here, you can see quite well that it's following a straight line. And why is that? It's because the path from this point to this point, if we are just moving the location of the object, which you can see we are, is a straight line. If we want to create an arc motion, we have to rotate the bone. And we have to rotate it around a pivot point. Now, why doesn't the 3D cursor pivot point work? Well, it's because the 3D cursor it's just the tool. It's not actually built into the rig anywhere. So in order to use this pivot point when interpolating the animation, what we need is not to change the location of this torso, but to rotate it around a pivot point, right? But let's see if we can take it a little bit further and just try to do a better job. So I'll start with this first key, and then I'll rotate it a little bit at a time. I'll try to be even with it, and let's see about that. This will follow a bit of a curve path, but you'll notice that the timing is kind of terrible. And if I wanted to even out the timing here, maybe I could do that. No, the spacing of the animation is even worse. Spacing is what's terrible. I used the wrong word. So, it's not very intuitive at this point how we fix the spacing of the keys. And even here, it's got this weird sort of halting point in the middle. So animating this way with the 3D cursor it's just kind of a pain to do. And it still isn't following a very perfect arc. So instead, let's go ahead and use this custom pivot point. Once I've got it at the location I like, I want to set a location keyframe, and I want to lock the location so that I don't accidentally move it. Let's also set the rotation and scale, I guess. And then let's go to the extreme, the end of the turn of the falling animation, and add a rotation keyframe, and we can go ahead and straighten that out. Just like that, right away, you can see that we've got our arc, and it's a much nicer arc. And if we want to edit the spacing of the frames, we select our pivot point here, and we've got one. We actually don't need anything except for the X rotation. See that? Everything else is not even really animated here. So we've just got this one curve that we can change and totally fix. In fact, that did a little bit more than fix. That kind of screwed it up. We can totally fix our spacing here. And you see it stays on that arc no matter how much we edit it. So basically the point of all this is that we can really help our animator out by giving them these tools. By the way, I want to also show you something that I noticed while I was doing animation tests for this, which is that the feet rotate farther than they're supposed to. See how they're like doubling the rotation of these controls? This is another reason why we do animation tests as riggers. It's important to understand the needs of your animator and check and make sure that you haven't screwed anything up. Now, usually I do the quality assurance at the end of a rig, but since we've detected a problem, let's go ahead and fix it now. And we don't need this animation anymore, so let's just get rid of it. Let's try to figure out what the deal is with this foot. Why is it copying the rotation twice? Now, I've investigated this by switching to FK, and I've noticed that we don't have this problem in FK. It's purely an IK thing. So what gives? Well, we know that our foot is copying rotation from this, and it should be inheriting its rotation from this. And if we look at this, we can see that our MECH IK foot is getting too much rotation applied. If we use our left bracket key to go back in the parenting hierarchy, we can get the counter pivot, and then we can get the pivot. You'll notice that the pivot has a copy rotation constraint, and it's copying its rotation in world space from this heel, and of course it's inheriting its rotation from the foot controller. The heel is also inheriting its rotation from the foot controller, so we end up copying this rotation plus this rotation for a total of twice as much rotation as we want. The remedy is very easy. We can just set it to copy in local space. Now it works just fine. So in order to fix this, we can go into our leg.l or .r group, doesn't matter, grab our IK foot group, and this is the copy rotation constraint that goes from the heel controller.
We just go ahead and force.
I don't know why it's not showing us the name right there, but it shows us over here, Control IK heel, and this bone is our IK pivot. So this is the constraint we're looking for. We're just going to set it to local, and you can already see that fixed it. Very nice. Now that we understand the purpose behind our movable pivot, and now that we've solved the problem that we encountered in our animation test by updating this copy rotation constraint, let's go back and make this movable pivot into a reusable node group that we can repeat as many times as we want. So I've selected the inherit node, the widget, the bone, constraint, and second bone, and its matrix and all that. Notice that I haven't selected that other inherit node, and I don't want the matrix going into the first bone. Press Ctrl G to make a group, and let's go ahead and name this parent, and the output should be called Movable-Pivot. And we need to have an adjustable name for this. So go ahead and add a concatenate strings node, and instead of doing a chiral ID the way we normally do, we're going to add the name input, I guess is fine. And after we attach the prefix to the base name, we're also going to add the suffix _pivot. And since this is a controller that the animator is going to control, I have it called control torso pivot. And of course we need to write torso in there. Let's duplicate all three of these nodes, and we'll call this one MECH for the prefix, and then _counter pivot. And you can see the result that it generates up at the top there. And you should be able to see it in the output also. Sometimes you can, sometimes you can't. I'll figure out why exactly it doesn't work every time, but pretty often you'll see that the bones and the concatenate string nodes, if you press F3 and then force display update, you can see they'll update and they'll show you their names. Now we can press, well, obviously this still works, right? And you can see it has the name that we set for it. And this force display update thing is a good way of checking the names of your bones. Again, F3 and then force Mantis display update, and it will force it to show you the name of the bones and stuff, and the results of the string concatenations. So that's a nice feature that I added recently. Let's go ahead and call this node group add movable pivot. And I also like to name or label the node. Press Ctrl-Shift-D to make another one. Oh, you know what?
Just in order to force this output to have the right name, we're going to do this. I'll fix this before very long. The fact that this display error causes no real problems is probably the only reason I haven't fixed it yet.
Now you can see that we have two of these pivots, and they're layered. Now there's one problem. That this guy right here should be inheriting its rotation. So let's go in here and just enable inherit rotation in the inherit node. Now it's working like a charm, doing exactly what we want. This is control torso and then control torso 1. And if we want to make that widget a different size so that they don't overlap in the viewport, let's go ahead and just set bone matrix length. And 0 is not going to work, but so like 0.75 will work. And now you can see that they have the proper size difference there, so you can see them apart. Finally, another cool thing about this is that if you want to, you can put them just anywhere you want, anywhere at all that seems reasonable. Duplicate it, pop it in there. As long as the orange ones are on first input and the first output, you can drag it and drop it, and it will just use the first input. So you'll notice I'm usually pretty careful to do that when I make groups. For the matrix, you can go ahead and do matrix of transform, or I mean, even if you just change the name and what have I done? Oh, it needs to have a matrix input. That's actually a bug. But yeah, we can do a matrix of transform, and then I'm going to fix that bug and then show you what it looks like when I fix it. But anyways, we can see that we have one of these movable pivots that follows the torso because it's now a child of the torso, and the torso is a child of these guys. So you can set up a whole chain of different pivots that you need for a specific animation or something, and it just works. And it's super helpful, super useful. Quite proud of that. I'm going to go and fix that bug, and then we'll get back to work. We'll do the arms next. All right, that bug is fixed, and you can see what it does when we disconnect the socket. So this is useful even if you don't have a matrix plugged in. I'll let you decide, where you want to put these movable pivots. If you want to put them in there at all, totally up to you. For this iteration of the mech rig, I'm going to put them before the torso. But in the first iteration, they were actually afterwards. At this point, we need to set up our arms. So let's add the bones for the shoulders. Make them children of the chest bone. This one, shoulder.l. Add a meta rig, shoulder.l. And of course, we can make this. We'll make all three of these children of the shoulder for now. We'll do the same thing over here. We'll go ahead and Control-Shift-D to duplicate these and keep the connection. Name it shoulder.r, and there. Let's unlock the rotation of this. Very good. Now for the arms, we can actually go ahead and just reuse this IKFK limb that we added earlier. So I'm just going to Control-C and copy that. And we're going to need to make some slight changes to it, of course, because right now it's naming everything as if it was a leg. So in order to actually have it be arm-like, we're going to do this. I wonder why it's not working.
Oh, it's because the IK handle parent is relevant here. We need a bone to go in there.
By the way, the error was caused by these meta-rig nodes looking for a bone that just doesn't exist. ThighArm.l, it doesn't make any sense. I thought I was being clever by changing the chiral ID, and obviously that ain't gonna work because there's no meta bones by that name. Yeah, we're gonna have to change this up, but we're gonna be able to reuse it almost entirely. All right, we're going to need to name segments. So segment 1, segment 2, and then end segment. Then parent, and then IK handle parent is already a fine name. So we need to go through and find our concatenate string nodes, and everywhere that it says shin and everywhere it says thigh, we're going to make those node group inputs. Segment 1 name, segment 2 name, and over here will be our segment 3 name. We're going to need to separate these segment bits out. Just delete the part where it says thigh, plug that in there, and there we go. Now call segment 1 upper arm and segment 2 lower arm. L. Now the tree can't execute right now because there's still errors, so we can't update the result of these concatenate string nodes, but that's okay. We'll figure it out. Oh, I still need to put the chiral ID in there. Cool. So I'm just going to duplicate this section. Hey, stop that. Duplicate this. Switch that to segment 2 name. Put that in there. Cool. And then finally for this last bit. I'm doing something stupid. Don't need the chiral ID in there twice. Control FK underscore segment 1 name, then chiral ID. Segment 2 name, then chiral ID. And for this last one, we'll do segment 3 name, and then chiral ID. There. And I usually like to put the chiral ID at the bottom of the tree because it tends to go underneath other things. But I like to put the drivers below that. There. Yeah, I think I will copy these 3 nodes here and just change the prefix as appropriate. And this sort of thing, it can be a little bit tedious, but it's not that hard to do. And frankly, if I had just done this from the beginning, we wouldn't have this problem. And of course, we're going to have to go down here to our legs and fix this up with thigh, shin, foot. Now I think it'll work. Yeah, there we go. There does appear to be some sort of problem with this guy. I'll just delete them and see if, no, regenerating the tree ain't gonna work. I think there's something wrong with our IK. Obviously this IKFK lim needs to have the proper IK input or else it won't work. And it needs to have the switch input from our parent, which you can see is defined over here in our other node group. So I'm just going to copy this and I'm going to start working on separating the left and the right arm into their own node groups. I like to have orange in and output nodes when I make node groups. I'll select this with Control G. Let's call this one shoulder, upper arm, lower arm. Plug the hand in there. What else? The input is the parent. We're also going to need a chiral ID so we can name this stuff. Lowercase s, so we can use the same one for the bone and the bone name in the meta rig. And let me check it. I don't think there is a hand.l in my there's no hand.r in my meta rig. So what we're going to do is we're going to grab the lower arm.l for our meta rig bone, and we're going to set a matrix location to the tail of this other bone. So point from bone matrix, head tail, set matrix location to that location, and our chiral ID is going in everywhere. .l. There we go. And of course we can duplicate this, plug all this stuff in. .r, press E to generate, and now we can work in symmetry if we want to. Cool. Now let's go ahead and add parent, which I can copy and paste from this leg group. Add a parent. Well, this one, parent arm, chiral ID. Parent for the arm parent, of course, will be our shoulder. Instead of grabbing from the thigh, it grabs from the upper arm. .l, just chiral ID. Very good. And it's already got its custom parameters set up because we copied and pasted. Very nice. So we'll just go ahead and add our drivers as before. One more thing, I want the parent of the IK handle to be something else. So we'll go ahead and add that in there. Well, this one, IK handle parent, put it above chiral ID. And for the IK handles, of course, we'll just make them children directly of the armature. All right, we are making something approaching progress, but our IK handle is it's doing something weird. And I'm not sure why that is. So let's try to find that out. So MECH IK lower arm is trying to go to MECH IK hand.l. Looks like it's going to the foot. I must have hard-coded something in the IK limb that I wasn't supposed to. See that? That should say segment 2 name. Now we've got a working arm component. We barely had to do anything. We just had to sort of update the IKFK limb we already had, and it works quite well. So there's actually something even cooler that we're going to do here, though, which makes the arms sort of unique and special. Something I've just noticed when playing around with this rig is that the arms, when we generate the tree, it defaults to IK. That's annoying. Of course, we can go and we can switch them every time, and now it behaves the way I want, but I don't want to have to switch it every time. Let's go into our node group, which first of all, we ought to name MECH arm. That's a good name. And now let's select our arm parent, which has the switches, this guy right here, and set FKIK to default to 0. Now, if we press E to generate our rig, config, you can see that it is in FK mode. Very nice. And let's name these nodes also arm.l and arm.r. Use capital letters. Cool. So, our mech's main role in this life is to stomp around on the battlefield, stomp, 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 and to twist its torso up and down and left and right, to focus on a target so that it can fire at it with its guns right here. So let's figure out how we can do that. I'll go ahead and add a new bone to the tree, and I'll call it target. And there's a few different ways you can make one bone track to another. IK, damp track, lock track, stretch to, and track to all work. But for what we're going to do, we want to use locked track, because this bone needs to stay locked on the x-axis. See, it turns on the x-axis. So we want to lock the x-axis, and we want to track the y-axis to point at this thing. And that moves the way we want it to. And this bone and the shoulder should also all follow it. But I'm not going to bother with that just yet, because let's do it with nodes. So let's go ahead and get started. So the first thing I'm going to do is I'm going to add a bone. I will do this inside of the arm, and I'm going to add a bone to do the tracking from the shoulder, and I'll call this one MECH shoulder tracking. See that? And then we're going to have to add the chiral identifier .l, have it use the same matrix as its parent, the shoulder bone, and plug that in there. And we're just going to need a locked track constraint. We need a target for it. Let's just add this empty as a target for now. So it looks like its x-axis is pointing forward and backward. So I think we want to point its x-axis at the empty and lock its y-axis. Yeah, and that looks like it's working. Of course, the arm isn't following it because maybe that should be right here. So what did we decide? We decided to lock on the y-axis and a track on the x-axis. Yeah, that's good. Oh, that's not good. Looks like it needs to be the -z-axis. There we go. Now let's go ahead and make a bone to be the target. We are going to have the bone be its own thing, but we're going to go ahead and it's going to need its own parent. So we're going to call this one aim target parent. And we're going to call this control arm aim target. And then we'll do .l, our chiral identifier. And for now, I'm just going to have the aim target parent be the chest bone. Press E to generate, and you can see the aim target is being placed on the lower arm bone because that's the metarig bone I selected. But I want to move that forward quite a bit. So let's go ahead and set matrix location. We'll get the point from bone matrix. And since I want to move this forward, I'm also going to do vector math and just add -5 or something in the y direction. And you can see what that does. If we make it like -15, see that? I'll make it -25. Really far away there. Cool. And now this is the target of the lock track constraint. And of course we need to be able to move it. We don't really care about rotation or scale. And we can see it's starting to work. So then we just need to add a bone to the upper arm and lower arm. And we'll just copy all of this because all of this is relevant. And we'll change shoulder to upper arm. We'll make the segment 1 its parent. And we'll plug that into the upper arm output. And this is another one of those really great benefits of using nodes, is that you can sort of build things piece by piece and update them. And as long as the node group in and outputs remain the same, there's just no trouble. It just all continues to work exactly the way you expect. We're going to need to set up these locked tracks to track in the right way. All right, well, that's obviously wrong. Let's see. So if we slide the influence around, we can see that it flips if we set it to X, and then it needs to be set to -X. But check this out. This guy over here flips if we set it to -X. So we're going to need to put a switch in here to choose between positive or -X for this locked track. And this other one, we did this one earlier. We need it to lock on the X and track on the Y. Oh, does that even do what I want? Maybe I want it to track on... Yeah, I think that's right. So what did I do here? Lock on Z. But we still need to choose between X and -X. So you see that one is going upside down. So in order to do that, I'm going to check the matrix of the target bone, and I'm going to get the point from that matrix. I'm going to separate the vector so that I can deal with just the X-axis. And I'm going to see if the X-axis is greater than or less than 0, because check this out. This one right here, the right one in edit mode has a less than 0x, and the left one has a positive 0x, and everything else about them is the same, or a positive 2. There's a negative number and a positive number. So we will use this to choose between two inputs and outputs. So I'll create a choose node, and we'll use this as the condition. We need to set these track axes variables, which I guess it's just it's just X and -X. Sometimes they've got funny names. So let's add a string input and another string input, and we'll have this one say X, this one say -X, plug them into our choices there, and plug those into the lock track. Press E to generate, and oh, it's going to give us an error. -X not found in this enum. So that's a little bit annoying, but that's just the way Blender's Python API does this. So track_X, track_-X. Why doesn't it get bigger? That's funny. Anyhow, you can see what that does. It makes it wrong on both sides. So I'll just reverse the orders, and there we go. And this, by the way, would be a really good thing to make a reusable group out of. So let's grab the logic part of this and press Control G, and we'll keep the string inputs. We need to change this to a string output, which is in here somewhere. We need to change the input to an X form. This stuff right now is just terrible, and it's because I've had to like slowly figure out how to do this stuff as I've built the add-on. I'm planning on cleaning up this majorly before too long, and but right now it is what it is. Please support me so that I can continue to build this add-on. Thank you. Anyhow, we will call this one, so the first one is track negative X, and so that's on the right side, and the second one, so right choice, left choice. Let's call this one choose right left. So we can just use one node for this. Our system mostly works. I think the shoulder should track. Maybe it should lock on different axes because I want it to twist the arm, which I believe is its Z axis. There we go. Cool. So yeah, so now we can control the aim of the bot. Very nice. We're going to improve this aim control quite a bit. So it would be nice if these guys had a common parent that I could use to move them both together. In fact, we've got a common parent we're pulling from, the aim target parent. But right now, the aim target parent is just a chest. So let's add a new bone. We're going to call it PRNT arm aim target, and we'll make this the aim target parent. Press E to generate, and because it doesn't have a matrix input, it goes right to the center. We're familiar with that by now, but it does what we want. We just need to put it in the right place. So go ahead and take this calculation right here, and we'll paste it. And that actually seems to be in the right place somehow, and it must be a mistake, because I was trying to grab the lower arm.L bone, which would put it right there. Let me just make it longer real quick, so that we can see it when we generate it. See that? It's the bigger one. We are going to simply get both points and linear interpolate between them. Put it between the lower arm.R and lower arm.L before adding this 25 negative Y to make it distant from the MECH, which we have done before. Aren't nodes fun? And we can see it's moving the way we want to. Very good. Now at this point, if we change the Y on our parent, it doesn't change the children. So I'd like to go into our arm group and just work on this math right here a little bit. That sets the location of the aim target. Force a display update so we can read arm aim target.L. What we want to do is we want to get the Y and the Z location of this, but keep the X location of this meta rig. So we can get a matrix of X form to grab our parent matrix. And the only problem with this is that it points directly to the center by default, which is no good. And it also messes up our choose left right node. So what we can do is we want to translate it to the left and right. So we can add a transformation matrix node, and we want to translate. We just want to get the X axis of the lower arm meta bone. So we're going to multiply X by 1, Y by 0, and Z by 0, so that we have just the X axis. And now we add a matrix transform node. These names are not great, to be honest. Press E, and you can see what that does. Set aim. But the good thing is that now we can go in here and we can change the location of this, and the aim targets follow. Very nice. Let's go ahead and add some custom objects now. Existing object node, we're going to go with WDGT locator. Plug that in there. And let me force a display update. Let's make these a lot smaller. I like that. I like making them kind of flat. And let's make the parent have an existing object. We'll do WDGT square, widget square. Plug that in the custom object. And I'd just like to make it wider on the x-axis, 0 on the y-axis so that it doesn't move forward like that. Very nice. So there's one more thing I'd like to do, which is to make it so that we can choose whether to have the aim go directly forward, as it does, or to a pinpoint. So I'll show you that. Pinpoint aiming, parallel aiming. Pinpoint aiming, parallel aiming. And fortunately, this is really easy to do. We're just going to add a copy location constraint to make the aim targets copy location from their parent. And the influence of this constraint will be another driver. So plug that in there, and I'll call this aim parallel pinpoint driver. And we'll add a custom parameter to our parent aim. And you can see what this does. See, we'll add a custom parameter to this guy, a float parameter. We're going to call it aim parallel pinpoint. And we'll add a switch node. Plug the parameter in there, plug the driver into the aim parallel pinpoint driver inputs, press E to generate, And now we have this controller to make them aim, parallel, or pinpoint. One more thing, I'd also like a driver to control whether they're doing the aiming at all. And let's do that on the individual aim target for each arm. Let's add a custom parameter, and I'll call this one use aim. And we'll make a switch. Plug use aim into the switch node. Plug the driver into the influence of the locked track constraint. And finally, we want these locked track bones. Force the display update so we can read their names. Shoulder tracking.l, hide. Upper arm tracking.l and lower arm tracking.l, hide them both. I'm liking this. I'm liking this a lot. We're very close to finished. Very good. And I think I like that this is turned off by default. We'll see. Now, it would be nice to be able to select different parents for this and for our IK foot. So for the next part of this tutorial, we're going to be making an IK parent switch or just a general parent switch node. In the next video, we'll make a switchable parent control using a schema group. I'd like to zero in on schema in its own video because it's a pretty big topic and we're going to be using it a lot going forward. So that will be in the next video. But, by way of a teaser, let me show you in the Mantis Rigging Nodes component pack just what it does. This IK foot has an IK parent controller, and you can see that they move differently based on which IK parent they have selected here. And this is extremely useful for animators who are doing different kinds of tasks. So you see we can have the foot stay planted even if we move the root around. We can have the foot follow the body even if the hips move, or we can have the foot follow the hips. And finally, we can have the foot follow the root controller. Useful in different scenarios when you're animating. That's the parent switch that we're going to do in the next video. All of my links are available at nodes.tools, including the source code for my add-on. Mantis is open source software, just like Blender. I have a firm conviction that software freedom leads to creative freedom, and that without free software, you can't really be creatively free because you're always going to have to pay some guy for access to your artwork and for the, you basically have to pay a tax for the right to be creative, which I'd like to prevent that. So if you'd like to help me help make Blender better for everyone by developing Mantis rigging nodes and eventually other node-based tools, because I've got lots of ideas and all I need is an opportunity to work on them. Then you can become a monthly supporter on Patreon or Locals, whichever one you prefer. And members will have access to a private Discord help room for Mantis, help designing your rigs, Python programming, anything else in the 3D art world. And not only that, but I will be posting texture packs occasionally as I make them. If you'd like to support me with a one-time help, I've got a whole bunch of textures on Gumroad, and I've got the Mantis Rigging Nodes component pack, which has 30 components that you can use for any character. It's got meta rigs for all of the Blender Human Base Mesh Bundle characters, and you can see some of the features right here, like a switchable IK parent for the foot, like we're going to build in the next video. And that's about it. I've got lots of ideas for where to take this stuff, and with your help, I can do it. So thank you, and happy blending.